All right. Can you all hear me okay? Brilliant stuff. Thank you all for coming to the London Summit. We're really excited to have you here. Just before I start the session, I want to make sure if you're in the right session. The title is ANT203, and it's Amazon Redshift powering FanDuel's success during peak sporting events. This is going to be a very interesting session where we'll talk about how FanDuel, America's #1 online sportsbook company, uses Amazon Redshift. We'll see from Kate Kim, who is the senior director at FanDuel, talk about how they use Amazon Redshift for peak workloads, such as Super Bowl and NFL. Remember, these are huge events in the US, and FanDuel serves them on their platform in terms of sportsbooks. My name is Siddhant Muralidhar, and I'm a Principal Technical Account Manager at AWS. So in terms of the agenda today, we'll understand why self-service analytics is really important. We'll also see how self-service analytics is on Amazon Redshift and the benefits that it offers. Self-service analytics is highly important, especially when you're running peak workloads, and we'll see why. We've been working with a lot of customers and understanding their architecture patterns, especially when they run peak workloads, when they run mission-critical workloads as well. And I'll walk you through some of these architecture patterns in the third section of the agenda. In terms of Redshift features, we have multiple of them where they can do the heavy lifting for you, and you can focus on your business outcomes and productivity. So we'll touch on those important features in this session as well. I'll then hand it over to Kate to talk about how they've been using Amazon Redshift for self-service analytics at FanDuel. So why is self-service analytics important, especially when you have to meet peak workload requirements? Before we answer that question, let's understand what a self-service means. So have you ever been to a grocery store and picked up a consumable from an aisle? It can be your favorite candy bar, or it can also be one of your consumables. But have you ever thought about how this has reached this particular aisle that I've picked it up from? Usually what happens is every time that the product is placed on the aisle, there's a lot of process that goes behind it. Right from sourcing raw materials, it gets into this manufacturing or a food processing plant. All the processing is done there, and they package it. After packaging them, they send it to these grocery stores. Once it reaches the grocery stores, somebody from that store will pick them up and place them into the right aisle, just so that it's convenient for you. Very similarly, we want to do this with data analytics. We want to take away all the heavy lifting as much as possible from our users so that they can focus on productivity. So in terms of requirements for self-service analytics, let's look at some data personas. So data engineers, the main thing that they want to do is they want to ingest and prepare data. This ingestion and preparing of data could be terabytes and sometimes petabytes of data. Once all of this data is prepared, they want to give it to the data scientists, developers, or even data analysts. And the analysts go through all of this data. They run a lot of queries. They really run heavy workloads on this platform and provide the data in such a way that it's either in terms of reports or business intelligence dashboards. The business users then use this data to make effective decisions. So these are the data users, and they just have to focus on what they're really good at and not about how does a cluster come up, how to provision hardware, security patches internally at the service, and so on. So we've seen a lot of customers, and especially in the industry, right? In the past few years, data has been generated significantly. So previously, data ingestion was happening about once in a month. It then became once in a week, led to a couple of days. And now we are seeing customers wanting to ingest data as soon as it's received through streaming ingestion. But there's a lot of pipelines that they also build. And this is really hard. Think about those pipelines going down. It's going to be an operational burden. So overall, if you look at the customer's requirement in general for self-service analytics, especially around compute, they want to get data insights in seconds. They want to also experience consistently high performance because they're running heavy workloads on them. And in addition to that, they want to get started with no modifications. But we also know how important costs are. everyone wants to get the best price performance for their peak workloads. So saving costs and staying on a budget is highly important and is a big requirement. So let's see how all of this comes within Amazon Redshift and how it can help you focus on productivity and the service does the heavy lifting. I know there's a lot happening on this slide, so let's split this up in 3 parts. So on this side of the slide, in terms of data, we're seeing a lot of data being ingested into this fully managed AI-powered data warehousing service. The types of data that we are seeing is transactional data, data from clickstream. We're also seeing data ingested from IoT devices, but also we're seeing customers ingesting data from application logs. And when I come to this side of the screen, insights. So how is this data being used? So a lot of analysts consume this data through queries, through BI dashboards, just to give this real-time analytics. But at the same time, all of this data is really important to make business-driven decisions. And to power all this, that's the one in the center. So Amazon Redshift scales from terabytes to petabytes. It also integrates a lot with machine learning. And talking about machine learning, it keeps a track of how your workloads are performing within your cluster. So it self-learns and it self-tunes itself. We've heard from customers that they also run a lot of Spark workloads and they want to integrate Amazon Redshift to it. So now you also have that integration built in. Customers have also told us that they run machine learning workloads and they just want to use SQL to perform inferencing of data or inferencing of models. And that's also possible with Amazon Redshift. A few months ago, we released Amazon Redshift Serverless to take away all the heavy lifting so that you can, again, focus on productivity. So talking about Redshift Serverless, as you can see at the bottom half of the screen, it's automated. It can automatically scale. It can also do a lot of advanced monitoring. And there's a lot of more features where you don't have to bother about it. It scales up and down as and when it's required. And if you look at the top half of the screen, it directly maps to the real-time requirements that the customers need in terms of self-service analytics. And that's get insights in data in seconds, experience consistently high performance, and also it's easy to get started with, but also it only scales when you need it. Think about the time when you needed to run reports early in the morning, and if you had a cluster that's running throughout the day, it was going to be very expensive. So with Redshift Serverless, it only spins up just the time when you have to run those reports, and then spins it back down if you have to do nothing. So that's about compute. In terms of autonomics, this is where performance comes into picture, and this is where self-service analytics helps. So within your Amazon Redshift data warehouse, there are multiple AI-powered optimizations. Now, we all know that having disk keys and sort keys within Amazon Redshift environment is highly important. So with ATO, automatic table optimization, it takes care of all of that. It does automatic sort keys, there's automatic disk keys directly on the cluster, especially on your tables. We also know that there's a lot happening on the data when we are modifying tables, and we know how important it is for us to run something like vacuums and deletes, and also run analyze on them. So with Amazon Redshift Serverless, it also does that for you. So you don't have to focus on running these manual jobs all the time. It all happens in the background. It also runs multiple vacuums at the same time, which is going to give you a better query performance when you run on those tables. But with that being said, Amazon Redshift has a lot of optimizations, and it also keeps a check of your cluster. So through Amazon Redshift Advisor, it gives you suggestions, which is directly populated on your console. And looking at those suggestions, you can take them and you can work on them at a time that suits you. And again, this is based on everything that's happening under the cluster. Now, if we move to user experience, analysts and business users and literally data users have told us we need a really nice query that integrates with Amazon Redshift. And this is where Amazon Redshift Query Editor comes into picture. So with Amazon Redshift Query Editor V2, which is our latest version, you can browse, create schema and tables just on the fly. It's very easy to use, And also the experience that we're seeing from our customers is really good. With this feature, let's assume that you have a query that you run and you just want to visualize the output. That can be done directly on the Redshift query editor v2 as well. But we also know how important security is. So with Amazon Redshift query editor v2, you can have it integrated with sign-on with IDP. Now you can also, when you're loading the data, you can also infer the schema directly when the data is being loaded from S3. But in this query editor, you can see a small little box on the top. And let's see what that is. That is Amazon Q Generative SQL. And this is a very, very cool feature because a lot of our customers have told us, can we just use natural language to run queries on Redshift? And this is the feature that enables you to do that. So think about, you want to query a table to get the top 10 items in a given catalog. All you need to do is to write, give me the top 10 items, or write a query to give me the top 10 items in this particular catalog. This translates your natural language into a query, which you can run across your database. All of this is personalized, it's conversational, and it's running in a secure environment. But what's the benefit of this? It increases productivity. So if you think about writing a query, it might take you minutes to write such a simple query, just so that your syntax is right, and so that it executes with performance. But writing natural language is much more easier. You can just write it in seconds. So this is where it increases a lot of productivity. We've also seen a lot of customers use this just to ask questions on what the database looks like. They don't have to go and study about the database by running multiple queries. Just through natural language, they will be able to find out what sort of data is on my cluster, on my tables rather, how am I going to interpret them, and so on. But the best thing about generative SQL is that it learns from your workloads. And it learns from the types of queries that you're running, just so that it improves accuracy as you're using them. Amazon Q Generative SQL is right now in preview. So please go try them out and let us know your feedback. It's currently going to be in preview in EMEA region as well, very soon. So now we've spoken about a lot of features on Amazon Redshift that's built in that can really do the heavy lifting for you. But to run peak workloads, especially a sales event if your company has it, or if you want to run peak sporting events, whether it's Super Bowl or NFL, architecting your Redshift environment is the crucial part. So let's start with an example. So we have a single cluster. And in this single cluster, you have a lot of workloads on them. So if you see at the bottom half of the screen, you have ETL going on maybe throughout the day. There's BI dashboards integrated. There's dev and QA users using the clusters. Data scientists are also running a lot of queries within the cluster. And at the same time, ad hoc users just come in and run heavy queries. While features like concurrency scaling and elastic resize could help in adding more compute just so that these users get a better experience, but sometimes we've also heard from customers that this could cause resource conflict. And if that happens, it's going to impact the downstream applications. So to solve this problem, we wanted to create workload isolation just between the types of use cases. And that's where data sharing comes into picture. So with data sharing, essentially what you can do is to break your cluster into multiple different parts or into multiple different environments and use each environment to do its own use case. So for instance, in this picture, you can see you have 4 different Redshift environments, each doing their own tasks. Like finance team is just using for their own deliverables. The data science is using for their own deliverables as well. So with data sharing, you can share live copies of data across clusters, not only within your account, but also cross-account. We've also seen some use cases where customers want to query a Redshift cluster based in the US from Sydney. So through Redshift data sharing, that's also possible. So you're going to get the transactional consistency across data whenever you share data between the 2 clusters. What we're also seeing is 2 types of trends within your data sharing architecture. So when customers move from a single cluster to a multi-cluster architecture, you have the hub and spoke architecture, which is what's shown here. So go back to this example that we spoke about, the single cluster architecture where everything was running just on a single provision cluster. So now through data sharing, what we've essentially done is we've broken it down. So we've said, let's have an ETL cluster that does solely ETL. Now this could be a provision cluster because it has to run throughout the day. We spun up an ad hoc query cluster, a dashboarding cluster, and a data science cluster. Now these clusters that I've spun up could be the consumer clusters. So data shared from the ETL cluster to these consumer clusters. And these consumer clusters can either be provisioned or it can be serverless. The other trend that we're seeing with our most advanced customers is also a data mesh architecture. And with a data mesh architecture, think of it like as one single cluster can act like a producer and a consumer. So in the industry, we're seeing a few customers where certain use cases have data being ingested only onto certain clusters. For example, the data science cluster may get its data from various sources. The finance cluster might get its data from various sources as well. But both of them have to work together so they can share data between each other. So when Kate comes and talks about how they've built their architecture, she'll talk a little bit more about how they've implemented the data mesh architecture at scale in their production workload. So let's put all of this together. Now, again, a lot happening on this slide, so let's break it down. So what you see in the center is Redshift through data sharing. So it can either be provision clusters or it can be a serverless cluster. Now this whole thing shows you how self-service analytics plays a very important role. On this side of the screen, you can see analytics on all data. So let's take a step back about manual pipelines, because I mentioned this at the start of the session. So every time data landed on S3, you had to create manual pipelines just so that that data comes into Redshift. So now with autocopy from Amazon S3, you don't even have to do that. With this feature, every time the data lands into S3, just with the configuration that you set up, it's going to be visible on your Redshift environment. So there's this autocopy happening. We've also seen customers where, for real-time predictive analysis, they want data directly from streaming technologies like MSK, Managed Service for Kafka, or from Kinesis, to be ingested into Redshift as soon as possible so that once the data is there, they can make effective decisions. But to do that, previously, they had to create another pipeline where they landed the data on S3, then created another pipeline so that it pushes to the Redshift cluster. So with this real-time streaming ingestion, now you can directly stream into Redshift. So you don't have to create those pipelines again. So you can maybe see how we are doing the heavy lifting for you so that you don't have to worry about creating and managing manual pipelines. We've also seen a lot of customers use DynamoDB, Amazon RDS, Amazon Aurora for multiple use cases. But they also have very specific use cases where that data has to be on Amazon Redshift. Now, this data is going to be very crucial when they run, again, peak events or peak workloads. So previously, if they had to do that, again, manual pipelines, they had to manage them. It's an operational burden. So with zero ETL, just with a few clicks and few configurations, which just take maybe a couple of minutes, it's possible to get that data from those data sources into Redshift. So similarly, you have federated query and Amazon Data Exchange integration. So on the other side of the screen now, let's look at how Redshift integrates with some of the other consumption patterns. So Redshift integrates with BI workloads. For example, your BI dashboards, it could be Tableau, it could be QuickSight. You have data APIs. And again, customers have told us that they want Redshift to be integrated with multiple services. So now, Redshift integrates with multiple analytics services, machine learning, and also some Gen AI applications. It also integrates with open source analytics engines as well. Well, all of this sounds great. When we run peak workloads, it's important that we test them. Also, when we start using these features, it's highly important that we run a POC and make sure that this is suitable for our workloads and it's not going to impact any downstream applications. Testing in any technology is very crucial. So the way you do performance testing on a high level is to ensure that you identify your business and functional requirements and then work backwards from it. Every time you run a test, make those relevant configuration changes and then rerun the test so that you can make data-driven decisions. So with all of this performance that Redshift is offering, internally we are seeing a lot of tests being done. And the results shows that on TP-CDS data, we are seeing 6 times better out-of-the-box price performance on Amazon Redshift. For peak workloads, especially around sales events or peak sporting events, a lot of analysts and data users generally use their BI dashboards. So if you see this graph, as the users increase, Redshift also scales very well, keeping the price as low as possible. So it's 7 times better in terms of price performance for BI dashboard workloads compared to some of our competitors. But running peak workloads is going to be very important, especially around resiliency. So with Amazon Redshift multi-availability zone, multi-AZ, you can now deploy Amazon Redshift clusters across 3 multiple availability zones, which increases your service SLA from 99.9% to 99.99% for mission-critical workloads. So let's summarize all of this together now. So with zero ETL, when you have to move data from Dynamo, RDS, or Aurora, we're seeing in our internal test for over 1 million transactions per minute, the latency is just 15 seconds. We spoke about how Redshift integrates with ML. So the number of inferences that's being done per day on Redshift is over 10 billion. We spoke about customers using streaming ingestion and directly pumping the data into Redshift. So we're seeing over 2.5 GB of data being processed every single second. And because of all this, there are over 10 billion queries that runs on the fleet today. And that's the reason over thousands and 10,000s of customers have been using Amazon Redshift. And one such customer is FanDuel, who's part of Flutter Entertainment. So I'll invite Kate now, who's traveled all the way from LA to come and be here with us. So let's give it up for her. So she'll talk to you about how FanDuel uses Amazon Redshift.
Thank you, Sid. Good afternoon. It's great to be here in London today. It's not as sunny as Southern California, but London is such an amazing city, and then I love to be here today. My name is Kay Kim. I am from FanDuel. And many of you probably recognize Flutter Entertainment. And Flutter Entertainment is the world's leading sports betting and gaming operator. And you probably recognize Sky Betting and Paddy Power, which are the big brands in the UK. So the FanDuel is the prominent US brands of the Flutter Entertainment. So today, what I'm going to talk about is that how at the FanDuel we have modernized a single legacy data warehouse using Redshift, moving on to a multi-cluster data mesh architecture, and how we empower the self-service analytics during the peak sporting events, American football. So FanDuel is America's #1 online sportsbook and premier mobile sports betting operator. And we have over 17 million registered users. We are multi-billion sports betting company in the United States. So what does data mean to FanDuel? We're a data-driven organization. Data is an asset for us, and it is an opportunity for us. We maximize the revenue, we protect the revenue utilizing the data. So for this reason, we built a data warehouse system many years ago. We leveraged Redshift, and we started with a centralized single data warehouse. So the data warehouse is a hub of the data that every line of the business is getting the data in and data out every single day. And one of the departments that I am going to highlight today is the risk and trading team. It is probably the most important data users within the FanDuel organization. They use the data from the data warehouse and then they generate, customer profiling and coming up with what would be the estimated revenue and then forecasting, customers' behavior. So football, American football, is at the heart of FanDuel business. So a lot of times we go by football calendar, NFL calendar. NFL is the biggest sport in the United States, probably combined. It's bigger than NBA, basketball, and MLB, baseball combined. So it is super critical for us to get prepared well in leading up to the NFL season and then finishing the NFL football season successfully as well. So over the course of past couple NFL seasons, the company had a huge success, growing so fast, enormously. And then the single data warehouse system we had built also grew. It has grown enormously as well. So we started solving more and more business problems, adding more data, adding more data services and servicing more data users. And that's when we started seeing a little bit of the negative signals, and this started back in 2023 Super Bowl. So the business was growing actually faster than what we can scale. So what you see here as 48% of query efficiency means that it's only utilizing 48% of the time of the query being executed, meaning that 52% of the time it is waiting in the queue doing really nothing. So these negative signals became a real challenge for us. So going back to the story of risk and trading team, they are the one who's generating customer insights and personalization on a daily basis. Their job started taking too long, 7 hours. 7 hours, during the 7 hours, the critical insights that would have been shared across the business, that was completely blocked. And then including the key metrics that they are generating, such as revenue, estimated revenue, and customer segmentation, could not be shared across the business, which would equate as $50,000 business value lost on a single day, every day. And the most importantly, no other queries could not finish until it is done. So the data warehouse we have built, because it was a single shared resource, it has become a tragedy of the commons. So then one giant, resource-intensive job was taking all the resources that data warehouse had to offer. So the data engineering team that I am belonging to, we were given the mission to solve this problem immediately. So first and foremost, we had to recover the runtime, but we had to solve this problem in a very specific way. So we had to stay on a budget. We could not just add more compute and throwing the money to solve this problem. So this is when we started looking at serverless as an option, putting all the heavy lifting to the AWS, and then we can handle the auto scaling of the compute using serverless. And then the another thing that we had to solve this problem with a real-time data to fresh data. So we had multiple ETL processes happening all the time in the data warehouse, and the fresh data, accessing to the fresh data for the analysts, that was a crucial business for us. So we could not build like data pipelines, moving the data along, because that would mean that data access would be delayed. So we started looking at data sharing and potentially a reverse data sharing, because the insights that was generated by risk and trading team in the data warehouse had to be instantaneously accessed by the rest of the business as well. And we had to unblock concurrent self-analytics that's done by hundreds of business analysts using the data warehouse. So we started looking at a potential solution of multi-cluster, which would horizontally expand the capacity of concurrent queries on a cluster base. So the journey that we had taken, because FanDuel had a Redshift cluster for quite some time, so we tried all the features and options that was offered from Redshift for quite some time. So first we tried going onto the right cluster node type, which was the RA3, and it solved the problem of the storage and compute separating for the performance. And then we also tried, we had implemented concurrency scaling. There were peak hours of maybe 1 hour, 2 hours of the intensive number of the queries that had to happen. And concurrency scaling had helped us to reduce some query queuing without spending the compute cost 24/7. And workload management, we designed very specific workload management to handle queries differently. So we have given a different priorities for depending on the query types, and we were able to handle some of the queries giving the priorities than the other. And we introduced a multiple query management rules to guardrail the resource from a ad hoc queries that is poorly written as well. So all these techniques, it helped us to solve problem to a degree, but not 100%. So we had to come up with a different game plan of solving this problem completely different way. So that's when the AWS started, new features, two critical new features. One is data sharing, and the other one was serverless. So the data sharing solved the problem of without adding another data pipelines at the end of the ETL, copying the data all over the different destinations. It gave us an idea to, we can maybe design a multi-data warehouse and allowing the data accessing instantaneously. And serverless was another feature that we took it very seriously, that AWS doing all the heavy lifting, and then it does automatic capacity scaling, and then you don't have to design when the compute goes up or compute goes down. So the conclusion was that we were meshing all the tech that we tried so far, and then came up with a completely new architecture. So just to recap our journey, we moved from a single cluster architecture to multi-cluster architecture. First, we moved from DC2 to RA3 node, and then we started leveraging data sharing to come up with a hub and spoke architecture that Sid was talking about. So first, we put the ETL cluster as a producer, and then put multiple consumers on a read-only queries. But that was not enough, because the data had to be cross-shared. And we started looking at data mesh architecture that comes with a different type of the node, and that comes with the data sharing and the reverse data sharing. So this was our final solution that started from a single shared data warehouse architecture to a multi-data mesh architecture. And we had given a risk and trading team their own data warehouse system as well. And then because they were only using 3 to 4 hours of the compute on a daily basis, it did not make any sense to give them a provisioned server at all. So we had made their data warehouse as a serverless option so that we can manage the cost more efficiently. And then the insights that they were generating back to their own data warehouse, it was shared across the multiple data warehouses in here. So started from a hub and spoke architecture, and then we extended to a data mesh architecture in here. So in this diagram, you can see some provisioned clusters, some are serverless clusters, and then for the same reason, BI Tableau dedicated consumer cluster was put on a serverless as well. This was a huge undertaking for data engineering team. We had to redesign everything, and then we had to maintain a business continuity so that no business is disturbed or disrupted with the change or the migration of the data warehouse system. So this was a huge undertaking, and it took us quite some time to come up with a new architecture. And then it finally paid out a positive outcome during 2024 Super Bowl. It is the biggest event for FanDuel, and I think we had a record high, sports betting transactions during 2024 Super Bowl. So the result was very successful. So we were able to meet all the goals that we wanted to achieve during the mission. So we were able to improve SLA for risk and trading teams 3 times better, and we maintained 75% of the query efficiency across multiple data warehouses. So it was a huge jump from 48% to 75% over the course of an year across the peak event. And then we were able to maintain the cost 4 times lower using serverless, and that was with 5 times bigger data volume growth. So actually the cost was a lot, cost efficient than having the provisioned cluster. So that all entails to $15 million worth of revenue upside per year. And we did a analyst sentiment survey at the end of a Super Bowl season, and everybody was very happy. They were happy that they didn't have to wait in the queue for very long time. So it was a phenomenal success and result for us. The one last thing that I wanted to highlight, that it would have not been possible, or it would have probably taken us longer time to get to the next level of our data warehousing system if we didn't have any collaboration or support with the AWS team. So we were invited to an AWS countdown. What that means is that from the beginning of NFL kickoff season to the final countdown, literally a final countdown of the Super Bowl, we met every day and we planned together what would be the right cost, what would be the right operational review, and then what would be the right architecture for our data warehouse team. And we were given a right access to the experts, and it wouldn't have not been possible. It would have been taken a longer time if we didn't get a proper support from enterprise team. So I want to bring Sid back to the stage, and then so that he can talk about AWS enterprise support. Thank you so much.
Thank you, Kate. That was really insightful. So we're coming to the end of the session, so let's talk a little bit about enterprise support. So I know most of you are already on enterprise support. For those of you who aren't, enterprise support is another support offering from AWS where we work very closely with customers on their cloud journey. We help customers reduce risk, whether it's in security-related aspects or its general architectural practices as well. We help our customers to optimize costs, implement best practices, and end of the day, increase operational resiliency. If you want to know a little bit more about enterprise support, there is a booth outside at the venue today, so please go have a chat with them and also with your account team, and you'll learn a bit more about enterprise support. So the key takeaways from this session is, when you're running peak workloads on Amazon Redshift, ensure you're taking into account self-service analytics, see what the service offers so that it can do the heavy lifting and you can focus on business outcomes. Amazon Q Generative SQL, go try it out. Give your users a better experience just to query your Redshift data warehouse through natural language. Account evaluation, so include your account team, get in touch with your AWS enterprise support so that your workload would be successful serving peak for peak events. So this is the end of the session, and I'd really like to thank all of you for attending it. Please do share some feedback. The QR code is up there, and see you soon. If you have any questions, we'll stick around here for a few minutes, and we'll be happy to chat. Thank you.